Now this data that I've collected would need to be presented in a way in which it is easily understood and inferred. So the investigator, or basically the person who's trying to collect the data, has to find out a lot of ways to present them in the form which is meaningful, easily understood, and give its main features at a glance. So let's try to take on some examples by which we can represent the data. So let's say I have marks of 10 students in a mathematics test. So there's the list. So this kind of data, when you see, would be raw data because it has not been processed till now. If you look at this data, can you tell me what are the highest marks a student got or what are the lowest? Obviously it will take you time because the data is still in its raw form. So what you can do is you can arrange this data in ascending order or descending order. That way you would get to know the minimum and the maximum marks. From here we can clearly see that the highest marks is 95 and the lowest is 25. And if I want to know the difference of highest to lowest, it would be 70. To know about this data and this representation of data in ascending or descending order, if you think about it, can be quite time consuming, particularly when the number of observations in an experiment is large. Let's take another example in which the observations are really large. Now, let's say I have marks of 30 students and I want to arrange this data now. Now, if I can use the logic that let's say if 5 people get 100 marks, I can just denote a 5 next to 100. So what I'll do is I'll write all the scores that people got in exam, and I'll write their corresponding frequencies. That means how many students got those marks. So this kind of representation is called ungrouped frequency distribution table, or simply a frequency distribution table. So now I can figure out the number of marks according to the number of students.